So looking at the Unit 3 review, we're going to solve each problem, showing all of our work. So for question number 1, for the function f of n equals n squared minus 5n, we're being asked to find f of -6. What that means is go to the function f. Anytime you see a variable, you're replacing it with -6. So f of -6 equals -6 squared minus 5 times -6. So that's my first step. For my second step, I just want to simplify. Remember, when you do this type of problems, you're evaluating a function at a specific variable. So f of -6 there on the left just stays the same. You don't do anything with it. So f of -6 equals, then I'm taking -6 and I'm squaring it. -6 times -6 is positive 36. Minus 5 times -6, -5 times -6 is positive 30. So f of -6 equals 36 plus 30, which is 66. And again, we're not doing anything with that f of -6. We're leaving it as it is. I think I warned you last week that in the past, some students had tried to divide by that -6. You don't. That just is the notation that we took the function and we put an input value of -6 into it. The answer we got was 66. So we're 2 points on your test. Again, I'm always giving you 1 point for showing me that initial step. If you would happen to calculate something incorrectly, I can still give you that partial credit when I can. For questions 2 and 3, we're asked to perform the given operations, and we're given two functions, g of x and h of x. For the first one, we're asked to find g minus h of x. H is closest to the x, doesn't really matter in this case because we're not plugging anything in. We're just going to take g of x minus h of x. So really this is g of x minus h of x. So I'm just going to take those two functions from the top and I'm going to copy them down. So 5x to the third minus 2x is g of x minus h of x, which is -x minus 7. Since I am subtracting, I want to get rid of that minus sign so I can combine like terms. You're just going to distribute it in. What that does is change all the signs that follow. So now we have a plus in between our parentheses and a positive x plus 7. Once you distribute that negative to the second set of parentheses, you're just going to go through and combine like terms. So first term I see is 5x to the third. There's no other x to the third, so I'm just bringing it down. That takes care of that term. Then I see a -2x. Well, -2x can get put with the plus x. So -2 plus 1 is -1 or just -x. And then down here you have a plus 7. Nothing goes with the plus 7, so I'm just going to write plus 7. So final answer for this one, 5x to the third minus x plus 7. Question number 3, we're asked to find f times g of x. That means we're going to take h of x and we're going to multiply it by g of x. So really I'm taking, h of x, which is -x minus 7, and I'm going to multiply it by 5x to the third minus 2x. You can FOIL that, you can double distribute, or you can box it, whichever way makes you happy. I'm just going to go ahead and box it. So 2 terms times 2 terms gives you a 2 by 2 box. So negative x minus 7 needs to go either on the top or the side, and then 5x to the third minus 2x. Multiply corresponding parts. So in my top left box, I have negative x times 5x to the third, which is negative 5x to the fourth. Negative 7 times 5x to the third gives us negative 35x to the third. For the bottom left box, we have negative x times negative 2x. Well, negative times negative is positive, so 2x squared. And then our bottom right box, negative 7 times negative 2x. Negative times negative is positive, so 14x. For my answer, I just need to go through and combine like terms if I have any. In this case, you actually don't have any like terms, so you're just going to write your long answer, negative 5x to the fourth minus 35x to the third plus 2x squared plus 14x. Keep in mind that when we write our answers, we always start with the biggest exponent and work our way down. So I started with x to the fourth, then x to the third, x squared, and then x. And this right here would be my final answer. This question here, again, is worth 2 points. Questions on these two? If I'm going too fast, holler at me and let me know. For questions 4 and 5, we're given 2 new functions, g of x and h of x. For question 4, we're asked to find g plus h of 3. So notice this right here has changed. In the last 2 problems, they were just x's. There's 2 ways you can solve this kind of problem. You can take h plus or g plus h and add them together and then plug in 3, or you can do it all at once. It does not matter. Probably the more organized way would be to do it in 2 steps. Separately, take h plus g and then substitute the 3. Let's try it that way. So g of x is 3x plus 2 plus h, which is negative 2x squared minus 6. Since this is addition right here, we don't have to worry about distributing anything. We just need to combine like terms. So negative 2x squared doesn't have any like terms. 3x doesn't have any like terms. But I can combine the negative 6 and the positive 2 to get negative 4. So this is g plus h, but now we have to take into consideration this 3 right here. What that means is we're going to go here and we're going to take out these 2 x's and replace them with 3's. So negative 2 times 3 squared plus 3 times 3 minus. So we've taken those x's out and replaced them with the 3 that we were given in the prop. Then we just want to simplify. So 3 squared, got to deal with this first. So 3 squared means 3 times 3, which is 9. 9 times the negative 2 that sits out front is negative 18. Plus 3 times 3 is 9 minus 4. So negative 18 plus 9 minus 4 gives you negative 13 as your final answer. So very similar to questions 2 and 3, except once you simplify, just plug in the number that they give you out at the end. Same way with question, oh, that's 3 points, by the way. We're working through that one. Question 5 is also worth 3 points. We're going to find h divided by g, and then we're going to plug in negative 2. So h divided by g would be negative 2, x squared minus 6 divided by 3x plus 2. 1 point for writing that down. Another point for substituting in the value that we're supposed to substitute in. In this case, it's -2. So in the places we see x, we're taking them out and we're replacing them with -2 because that's what we were given to substitute. So -2 times x squared, which is -2, squared minus 6 divided by 3. Again, plugging in our -2 plus 2. Then we're just going to simplify. So when we simplify, remember exponents always come first. So in the numerator, -2 squared means -2 times -2, which is 4. So this becomes a 4. Then I'm going to multiply it by the -2 out front to get -8. Bring down the -6. And then for the denominator, we're going to take 3 times -2 to get -6 plus 2. Now we're going to work our way across the top. -8 minus 6 is -14. Divided by -6 plus 2, which is -4. At this point, you have two options. You can either simplify this to be the simplest fraction, or you can just compute -14 divided by -4 in your calculator. I don't care. If you simplify this fraction, you can divide both top and bottom by -2 to get 7/2. Or if you type it in your calculator to get the decimal, it's 3.5. So either answer works. Just make sure you can't leave a negative divided by negative. You've got to simplify that. Questions on the front page? All right, question number 6. So here we're given a composition of function. I know it's a composition because right here in the middle, I have that little open circle. That's a composition, meaning take the function closest to x and plug that into the other function. So we're going to take all of g of x and we're going to plug it into f. So we're going to take all of this and we're going to plug it in right here. So we have 6, and then we're not writing that x, we're writing 2x squared minus 5. Then the rest of f plus 14. Then we're just going to simplify. Well, to simplify this, we need to distribute the 6. So 6 times 2x squared is 12x squared. 6 times -5 is -30. Bring down the plus 14. To simplify this, all you've got to do is combine like terms right here. So 12x squared minus 16 would be my final answer. When we look at question number 7, notice again we have a composition. We're taking f of g, but this time they've taken the x out and replaced it with 6. So we're going to find f of g of x first, then we're going to take our x's out and replace them with 6 at the end. So g is closest to the x value we're plugging in, so we're going to take it and plug it into f. So this right here is getting plugged in right here for x. So we're going to have 1/2 from the original And then we're plugging in 8x minus 10. Then bring down the plus 9. So we've taken that x out and we've replaced it with the 8x minus 10 from the second equation. Then we want to simplify this. Well, to simplify it, we're going to distribute the 1/2. If I take 1/2 times 8, 1/2 times 8 is 4, so now we have 4x. 1/2 times negative 10 is negative 5, so 4x minus 5, bring down the plus 9. Combine like terms, so you have 4x plus 4. So this is f of g of x. But keep in mind, we were asked to find an x value of 6. So we're going to take this 4x plus 4 and we're going to plug in 6. If I plug in 6, that's 4 times 6 plus 4. Well, 4 times 6 is 24. 24 plus 4 gives us an answer of 28. So this right here would be our absolute final answer. There is another way you can solve this same problem a different way. It takes more steps, but it's still accurate. You'll still get an answer of 28. If you'd like to see that, I'll explain it to you later. This is the easiest, most straightforward way to do it. Questions on this one? Moving down to question number 8, determine if the relation is a function and then explain your answer. So to determine whether this is a function or not, we have to, first of all, look at our x values. When we look at our x values, we need to decide if there are any x's that repeat. Are there any x values on this list more than once? No, nothing repeats, so it's automatically a function. So there's lots of different ways you can explain your answer. You can tell me that no x values repeat in the domain. You could tell me that every input has exactly one output. Keep in mind on your test, if you get to this question and there's more than one x value, so say there are 2 -2's on your list, you've got to look to see if they have different y values. If they have different y values, it's not a function. Then you could tell me that there's a value in the domain that repeats more than once with 2 different y values. Remember, this is where we talked about the pop machine. If I go to the pop machine and I push the button for Mountain Dew, I expect it to give me Mountain Dew every single time. I shouldn't get a Mountain Dew one time and a Dr. Pepper the next. So it's about that consistency. So this one here is worth 2 points. You get 1 for choosing whether it's a function or not a function, and then another point for your explanation. Question 9 is a 3-point problem. So question number 9, we're being asked to find the inverse. Remember, when you find the inverse, you're looking for opposites. So when I look at this, I know I'm going to have the opposite of -11 in my answer. So I know I'm going to have a positive 11 somewhere in my answer. I have a power of 3, which means I'm going to have a cube root in my answer. And then I have a -4, which means I'm going to have a +4 in my answer. So I know I have all 3 of these things in my answer before I've even started, just looking at the original. So think back to our steps to find inverses. The first step is always to take out the function notation and replace it with y. The second step, we're going to switch the x and the y. I have some students who automatically skip to this step. That's perfectly okay. So they just combine this first step and the second step in one line. So they take f of x out and switch it, and that's okay. So there's 1 point right there. As we keep moving, we need to isolate the third power. So we want to get this right here by itself so we can cube root it. So we've got to get rid of that -4 hanging out at the end. So we've got to add 4 to both sides. So now we have x plus 4 equals, in parentheses, y minus 11 to the third power. To get rid of that third power, the inverse or the opposite of the third power is the cube root or the third root. So we're going to take both sides to the third root. On the right side, the cube and the cube root's going to cancel, leaving us with y minus 11 on the right. And now on the left, we just have the cube root of x plus 4. I can't take the cube root of x plus 4, so we're just leaving it as it is. We're almost done. We've almost got y by itself. Now we need to get rid of that -11. So we're going to add 11 to both sides. So the cube root of x plus 4 plus 11. Notice that 11 cannot be put underneath the cube root. So it can't get put underneath here. That cube root's protecting that x plus 4. Then the last thing we want to do is write this in inverse notation. So f inverse of x equals, and then we're just copying this down over here. So the cube root of x plus 4 plus 11. And then double check, do we have all 3 things we said we should have had at the beginning? Well, we have a plus 11, we have a cube root, and we have a plus 4, so it's more than likely we did things correctly. Moving on to question number 10, another inverse problem. This time we're given a radical in there. So again, I always start by finding my opposites. I have a 5th root, which means I'm looking for an exponent of a 5. I have a -5, so I should have a +5. And then I have a +6, so in the end I should have a -6. I know all 3 of these things should be in my final answer in some way, shape, or form. So we're going to follow the same steps we did on the last one. First step, take f of x out and replace it with y. Step number 2, we're going to switch x and y. Once we switch x and y, we want to solve for y, but first we've got to isolate that 5th root. So we're going to subtract 6 from both sides. So x minus 6 on the left equals the 5th root of y minus 5. Now that the 5th root is isolated, we can go ahead and raise things to the 5th power. So I'm raising the right side to the 5th power and the left side. On the right side, the 5th root and the 5th power cancel each other out, leaving you with y minus 5. On the right side, we are going to leave it as x minus 6 to the 5th power. Technically, I could be really mean and make you multiply that times itself 5 times, but it would be ridiculous. I would not do that to you. I could, but I'm not going to. There's no reason for you to multiply that times itself 5 times. So then next step, we're going to get that y by itself by adding 5 to both sides. So in parentheses, x minus 6 to the 5th power plus 5 equals y. Since y is by itself, we're going to go ahead and write this in function or inverse notation. F inverse of x equals, and we had x minus 6 to the 5th power plus 5. And then again, I'm just double checking to make sure I've got those same three things I said I would have, and I do. So I have the 5th power, the plus 5, and the minus 6. Questions on this one? It is again worth 3 points. Question number 11, state if the given functions are inverses of each other. You cannot just write yes or no and get full credit. You have to show me how you know they're inverses or they're not inverses of each other. So pick one of them, it doesn't matter which one, and find the inverse of it. If it exactly matches the other one, then they're inverses. If it doesn't, they're not. So I'm gonna pick the bottom one. Oops, I missed it. So I'm going to take this one and I'm going to find the inverse of it to see if it equals the simpler one. So I'm going to take the hardest one, the one that looks the hardest, and find the inverse of it. So I don't have to do all the hard work. It can be done the other way, I promise. There's actually a long drawn out process that you can do this as well, but this is the shortest way to do it. I'm all about finding the shortest way to do things. So to find the inverse of this one, we're going to take f of x out and replace it with y. For the second step, we're going to switch x and y. So x equals the cube root of y minus 5 divided by 4. Oops, I forgot. Now, when I look at the right side, everything on the right side is included underneath that cube root. So since the entire right side's underneath that cube root, I want to cube both sides to cancel the cube root out. Conveniently, when I cube the left side, it's just x, so it's just going to become x cubed equals y minus 5 divided by 4. I'm still trying to solve for y. Y is stuck in that fraction. If I want to get rid of that fraction, I'm going to multiply by the denominator on both sides. So I'm going to multiply both sides by 4. So 4 times x to the third is just 4x to the third. And then the 4's cancel out on the right side, leaving us with y minus 5. To get y by itself, I've got one last step. I've got to get rid of that minus 5. Easiest way to do it, add 5. So we found that the inverse is equal to 4x to the third plus 5. So we're going to check to see if this exactly matches the other problem. Are they exactly the same? 4x squared plus 5, 4x squared plus 5. They do match, so yes, these are inverses. You could have taken g of x and also found the inverse. The The tricky thing there is a lot of times students don't take the cube root all the way down to the bottom for the whole fraction on the right side, and then I have to count off points, which is no fun. This one is actually worth 5 points. Questions on this one? Okay. Question number 12 tells us to find all the zeros of f of x equals x to the third minus 7x squared plus 12x. So we've got 3 terms there. If we're finding the zeros, that highly likely that we're going to have to factor. So if I have to factor this, what do you notice about all 3 terms? So they all have a greatest common factor of x, so we're taking out the greatest common factor of x to start off. So first term, x to the third, if I take out 1x, that leaves me with x squared. Minus 7x squared, if I take out an x, I have minus 7x. 12x, if I take out an x, that just leaves me with 12. So now I have x, and then in parentheses, x squared minus 7x plus 12. Well, anytime I have x squared here in 3 terms, high chance that it's going to be an asterisk problem. So 1 in the top left and top right, negative 7 in the bottom middle, and 12 times 1, which is 12 in the top middle. So I'm looking for 2 numbers that multiply to give me 12, but add to give me negative 7. Only option is negative 3 and negative 4. So neither one of these fractions reduce, so I'm going to have 1x minus 3 and 1x minus 4. Don't forget to bring the x down out front, and then we're going to have x minus 3, x minus 4. Then we're going to use that zero product property. We have 3 things being multiplied together, and their product is 0, which means one of them, or more than one of them, has to be 0. So the first one, x equals 0, that one's already done for you. Whoops. For the second one, we're going to have x minus 3 equals 0. Add 3 to both sides, so x equals 3. There's another answer. And then this one, x minus 4 equals 0, which means x equals 4. So we're looking for the answer that has 0, 3, and 4 in it, which is letter C. Again, make sure you're showing work on your problems. Don't just circle an answer because it's multiple choice. I've got to see some kind of work. You want full credit. Question 13 says find all zeros, real or complex, of this function f of x equals 3x to the third minus x squared minus 8x plus 2. First thing that stands out to me is it's 4 terms with no greatest common factor. Since it's 4 terms with no greatest common factor, we only have one option to factor by grouping. When we factor by grouping, we split it in half. We take the greatest common factor of the left side and then the greatest common factor of the right side. So we're going to look at the greatest common factor of these 2 terms first. I can factor out x squared from both of those terms. If I factor out x squared from both of those, 4x to the third, take out x squared is just 4x. Tricky thing, if I take negative x squared and I take out x squared, there's a negative 1 that lingers there. Because x squared divided by x squared is 1, and then you have a negative divided by positive, so it's negative. A lot of times students want to leave that term out. And I know we've talked, after your split, you always bring down the sign. In this case, it's going to be negative. So whatever you factor out is going to be negative. So I'm looking at negative 8x plus 2. Greatest common factor there is going to be 2, or in this case, negative 2. So we're going to divide both terms by negative 2. So negative 8x divided by negative 2. Negative divided by negative is positive. 8 divided by 2 is 4. We're not taking out any x's, so it just gets brought down. For the second term, we're taking positive 2 divided by negative 2. Well, positive divided by negative is negative. 2 divided by 2 is 1. If you've done this correctly, your two sets of parentheses should match. Same thing's true on your test. The signs have to match, or you need to go back and figure out where you did something wrong. Don't just change the signs so they match. Find the root of the issue. So now that we've gotten this far, our parentheses get brought down together. So 4x minus 1. And then the oddballs, or the x squared minus 2, get put into the second set, or the other set of parentheses. Still equals 0. So now we have two sets of parentheses being multiplied together and their product is 0. The 0 product property tells us that one or both of these have to equal 0. So 4x minus 1 equals 0. X squared minus 2 equals 0. Set them both equal to 0. The first one's a tad bit easier because there's no x squared in it. We would add 1 to both sides to get 4x equals 1. Divide both sides by 4, and x equals 1/4. There's one answer. And like I said just a minute ago, this one is trickier because it has x squared in it. You're still going to start off by adding 2 to both sides. That just gives you x squared equals 2. But to get rid of that x squared, you have to take the opposite of squaring an x. You're going to square root it. The tricky thing is when you put in a square root on both sides, you must put in a plus or minus. Because we inserted the square root, we would have x equals, because the square and the square root cancel on the left, plus or minus the square root of 2. We're not going to simplify the square root of 2. We're just going to leave it as the square root of 2. We're not going to give the decimal equivalent. Sometimes you'll see people who break it apart and say they have 3 answers, the 1/4, and then positive square root of 2, and then they'll write negative square root of 2 separately. You don't have to do that, but you can if you want to. Moving on to question 14, we're going to use this function to answer parts A and B. So the first thing we're being asked to do is find the zeros of the function. What that means is you're going to set it equal to 0 and factor it. I'm going to scroll down so I can fit it all on my screen. Why is that? So to find the zeros, we would have 0 equals negative x to the third plus 5x. When I look at that, it's 2 terms. So I know I can't use my asterisks, but it has a greatest common factor. So factor out, you can either factor out a negative x or a positive x, it doesn't matter. Some students take out a negative because the first term's negative. Doesn't really matter in this case. Let's take out a negative x. So if we take out a negative x, that leaves us with x squared minus 5. X squared minus 5 looks like it's going to be a difference of squares because you have x squared first, then you have a minus sign, but 5 is not a perfect square, so I can't use a difference of squares. So this is going to be a problem kind of like the last one, where we're just going to have to set it equal to 0, square root both sides. So for this term here, we're going to have negative x equals 0. Well, that just means that x equals 0. There's one solution. For the second one, we're going to have, I'm going to go, over here. We're going to have x squared minus 5 equals 0. We are going to add 5 to both sides, so x squared equals 5. And again, since we have x squared, we've got to get rid of that x squared by square rooting both sides. When we square root it, we've got to put in that plus or minus. So x equals plus or minus the square root of 5. But since we're being asked to graph it, remember when we find the zeros, that's where our graph is crossing the x-axis. We're finding the x values of where your graph crosses the x-axis. I'm going to go ahead and take and figure out what the square root of 5 is approximately. If I type the square root of 5 into my calculator, I get 2.2. So when I go to graph this, I know I'm going to have points where my graph crosses the x-axis at 0. So x-axis, I'm going to 0, and I'm going to put a point. And then I'm going to go to positive 2.2, and I'm going to go to negative 2.2. There's a bunch of different ways you could go from here. So one thing you could do to figure out the flow of my graph, remember we have a cubic function. We talked about parent functions the other day. Your cubic function's either going to look like this or it's going to look like this. We've got to figure out which way it looks. To do that, you can just make an XY table. I would just use -3 and +3, plug them back into the original. If I plug in -3, I get +12. If I plug in +3, I get -12. What that means is if I go to 312, actually doesn't even fit on my graph, it would be up here somewhere. And then 3 -12 would be way down here in La La Land off my graph. So, you're fine.
Where are you plugging that -3?
Into this original right up here.
Okay.
So -x to the third plus 5x. Really, all I'm checking for is the general shape. Your graph should look like a cubic. It should start high, go down low. I'm not checking for accuracy of the points in the middle. I'm checking for general shape. So you could draw your graph like this. You could draw your graph like this. Oops, I missed my point. Like, I'm not checking, like, either one of those graphs would be okay with me. I'm not checking how high or low your hills and valleys are. I'm just making sure if you're supposed to start high and end low, you're starting high and ending low. If you're supposed to start low and end high, you're starting high or low and ending high. That question's worth 4 points. Questions on this one? Question 15, we're graphing a piecewise function. So remember, piecewise just means for different portions of the domain, we're following a different graph. So for this one, any x value that's less than or equal to -4, we're going to use x plus 2. So we're going to do this part first. So I'm going to pick any x value that's less than or equal to -4, and I'm going to plug it in to find y. So I'm going to start with -4 because x can be less than or equal to -4. So -4 is the first number I'm going to plug in. That just means I'm taking -4 plus 2, which is -2. So on my graph, I'm going to graph -4, -2. Then I'm gonna pick another number just so I can figure out where this goes. Let's do -6. -6 plus 2 is -4. So I'm gonna graph the ordered pair -6, -4. I could plug in more numbers to make sure I'm accurate. I could plug in -8. If you would plug in -8, -8 plus 2 is -6. It would give you this point here, but you get the gist. So for this portion of my graph, this portion of my graph continues to the left. It does not continue to the right because it stops when it gets to 4. That's part of the piecewise portion. So that's half of my graph. We've taken care of that top part of my piecewise function. Now we're going to do it again, but this time we're concerned about any x value that's greater than -4. So now we're going to this this portion here. So now we need any number that's greater than -4. I'm going to go to -3. If I take -3 times -3 minus 7, well, -3 times -3 is 9. 9 minus 7 is 2. So I'm going to graph the ordered pair -3, 2. And again, I got to keep picking numbers that are greater than -4. Well, the next one I would pick would probably be 0 because that's an easy one. If I take 0 times -3, that's 0 minus 7 is -7. So I'm going to have the order pair 0, -7 on my graph. The tricky part here is your graph continues on all the way until it meets -4, but it does not touch -4. A lot of times you'll see people put open circles there saying, hey, this gets really, really, really close to -4, because I could technically plug in any number greater than -4. I could take -3.9999999 because it's really close to -4, but technically it can't touch it. So that would be my final graph. So two pieces may not look anything alike. In this case, they kind of don't look alike. They don't meet in the middle. But this is my piecewise graph. Questions on this one? Before my favorite problems on the test. The easy ones. Question 16, describe the transformations from the parent function f of x equals the square root of x, the absolute value of x, represented by the equation g of x equals the absolute value of x plus 4 minus 1. So remember, the easy one to remember, the one out at the end, tells you how far up or how far down. In this case, if it's -1, I'm moving down 1. So at this point, I actually know that this one's wrong and this one's wrong, because these two both have down 1 in them. I know I got a 50-50 shot of it being C or D. But I'm going to take that further. I'm not going to guess. And I'm going to determine this +4 going to tell me left or right. Since it's inside, inside's always opposite of the sign. So instead of +4, I'm thinking -4. -4, would that move me left or right? Left. So this would move me left 4, which is letter D. So left 4, down 1 is letter D. Yep, that's it. That's why I said these are my favorite questions. People tend to get questions 16 all the way on correct on this test. No pressure. Question 17, we have the parent function x squared shown in our graph. And then we're going to take this graph and make the two shifts based off the equation they give us. The first thing I want you to do on your test when you do this question is write down the shifts that you are supposed to do. So again, I always tend to start out at the end because it's the easiest. This -2 hanging out at the end tells me I'm moving down 2. The -3 on the inside, since it's inside, you're going opposite. So instead of thinking -3 to figure out my shift left or right, I'm thinking +3, which moves me right 3. I promise you, if you take the time to write this down, but you happen to graph it incorrectly, I will still give you half credit. It didn't take us that long to write down 2 and write 3. So please take the time to do that in case you would happen to mess up your graph. It does happen sometimes, and that's okay. So when we have a parabola, keep in mind we always have those 5 points of perfect intersection. So we're going to take these 5 points and we're going to move them. We're going to pick them each up and we're going to move them down 2 and write 3. So I'm going to start up here at the right. I'm going to pick this point up right here. I'm going to move it down 2. Then I'm going to turn and go right 3. If I go down 2, right 3, my new point is right here on the edge. I'm going to do that with each of these 5 points. I'm going to pick the next one up. I'm going down 2. I'm going to turn and I'm going right 3. And right here is where my new point's going to be located. For the vertex down here at 0, 0, again, I'm picking it up. I'm going down 2, turning, going right 3, and the new point's going to be right there. Let's see. Once you do that with all 5 points, you're just going to connect the dots. Remember, your new graph should look exactly like the original, except picked up and moved down 2 and right 3. The same thing's true on your test. On your test, you're going to have the same exact graph as this one. I'm just going to change the 2 numbers. So your shifts are going to change, but the original graph is going to remain x squared. You're still going to have a parabola with those exact 5 points as the original. Questions on this one? Now we're getting into direct and joint variation. These are our proportion problems. If y varies directly as x and y equals 21 when x equals 12, those two get paired together. X is 12 when y is 21, those get stuck together. Find y when x equals 8. We're finding y when x equals 8. So now we're going to make our proportion. Doesn't matter how you set it. The first fraction up as long as you're consistent on the second fraction. So I'm going to do y over x equals y over x. So my first 2 that go together is 21 and 12. So I'm going to take 21 because that's y, 12 because that's x. Those get stuck together. Then I'm gonna find y when x is 8. So for my second fraction, I'm gonna leave y on top, but I do know that x being 8 goes with it. Now I'm gonna cross multiply. I'm gonna take 12 times y to get 12y. I'm gonna take 21 times 8 to get 168. Once I get here, I'm trying to get y by itself, so I'm gonna divide both sides by 12. So y equals 14. Questions on this one? All right, flipping to the back side. I warned you when we did this lesson that there's a question exactly like this on your test, and here it is. So here we're talking about the number of gallons of fuel used on a trip that varies directly with the number of miles traveled. If a trip of 250 miles requires 10 gallons of fuel, those two numbers go together. How many gallons are required for a trip of 400 miles? So we're finding the gallons that go with 400 miles. I don't care if you respond in a complete sentence. You could just label your answer and I'll be okay with it. So to set up my proportion, I'm going to do miles divided by gallons. So for my first fraction of my proportion, I'm going to do the red part that goes together. I'm going to do the 250 miles divided by 10 gallons. That's going to equal miles divided by gallons. Well, for the second portion, we're being asked how many gallons for 400 miles. The miles goes on top, so 400 on top. I'm going to put G for gallons in the bottom. Cross multiply. When I cross multiply, I'm taking 250 times G, which is 250 G, equals the other diagonal. 400 times 10 is 4,000. So 250 G equals 4,000. We're going to divide both sides by 250 to get G equals 16 gallons. So if we were wanting to travel 400 miles, we should be prepared to buy 16 gallons of gas, or to use 16 gallons of gas in our vehicle. Questions on this one? All right. Last one. So the cost of materials for a deck, I think the one we talked about on your notes was we were buying flooring and not a deck. So similar, but a little bit different. Varies jointly with the width and the length. That tells us that the width and the length are going to get paired together. So this time we've got three numbers. We're going to have a cost, a width, and a length right there. There's one triple that goes together. Then we're being asked to find the cost, and then we're given the width and the length. So when I set these up, I'm going to do cost on top, width times length in the denominator. So that's my game plan for setting this up. So the first set of information I was given, the cost was $424.80. That's going on top. And then for the denominator, I'm going to take the width times the length. 18 times 10. If you go ahead and multiply it together, that's fine. And then I'm going to set up my second fraction exactly the same. The cost, which we don't know, so I'm just going to put C for cost, divided by the width times the length, or the length times the width, 7 times 22. And then I'm going to multiply, cross multiply. So 18 times 10 times C is 180C. 424.8 times 7 times 22 is 65,419.20 cents. To get the total cost, we're going to have to divide by 180. So divide both sides by 180 to get the cost equals $363.44. Again, since that's cost, I'm just going to label it dollars. I don't know why I wrote that so crooked, but you get the gist. So again, since these are word problems, you need to label them in some way, shape, or form. This one's money, so we just put a $sign. The last one was gallons, so we just labeled it gallons. You don't have to write a whole sentence that explains your answer in relation to the question. Just label it appropriately.